Let's do one more example on how we can determine non-right angle vectors. So in this example, we need to determine the displacement of a hiker who has traveled 52.4 meters due west, then walks 112 meters at 39 degrees west of south. So in this question, in the first leg, the hiker travels 52.4 meters due west. He then turns and travels 112 meters at 39 degrees west of south. And what we're going to do is we want to figure out the total displacement of the trip. What is the displacement? Again, we need to also determine the angle. So to do this, our first step is to find the x and y components of each part of the trip. In the first leg of the trip, he is traveling 52.4 meters west. So that means he is only traveling horizontally. He does not travel vertically at all. So our total displacement 1 is equal to 52.4 meters. Our displacement in the x direction, again, is 52.4 meters. And our displacement in the y direction is 0. He is not traveling vertically at all. That is pretty easy when it's only in one direction. But now we need to determine the x and y components of his second leg of the trip. So I'm going to redraw below his second leg of the trip. He traveled 112 meters at an angle of 39 degrees west of south. Means he's starting south and he's heading west 39 degrees. We now want to determine what is the x and y components of the trip. So we have the displacement 2 in the x direction, horizontally. We have the displacement 2 y, or vertically. Again, if this angle on the outside is 39 degrees here, that means this angle is 39 degrees there. On this one, our displacement, our total displacement is 112 meters. To find our x component, we're going to use the sine of 39 degrees is equal to the displacement in the x direction divided by 112 meters. Why I use sine is because if we're using the 39 degrees, it's the opposite over the hypotenuse. The opposite over the hypotenuse. So if I rearrange, d2 in the x direction is equal to 112 meters times the sine of 39 degrees. And when you calculate and solve, you're going to get an answer of 70.48 meters. We can do the same thing now for our y component. In our y component, we can take now the cosine of 39 degrees is equal to displacement 2 in the y direction divided by 112 meters. Again, the reason we do that is because for cosine we have, or we want to solve for the adjacent, and we're given the hypotenuse. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. So when we rearrange, d2 in the y direction is equal to 112 meters times cosine of 39 degrees. When you calculate and solve, you are going to get an answer of 87.04 meters. Good. So now that we've determined the horizontal and vertical components of each leg of the trip, we need to create a total vector addition diagram. So to create our total diagram, we are going to determine our x component is going to be equal to our x component of the first leg, 52.4 meters, plus 70.48 meters, the x component of our second leg. So 52.4 meters plus 70.49 meters is going to give you an answer of 122.88 meters. We are going to do the same thing for our y component, but in our first leg of the trip, we traveled 0 meters in our y component. So it is just going to be equal to the y component of the second leg of the trip. So our dy, our total total vertical distance traveled is 87.04 meters. So if we use this to draw a vector addition diagram, we are heading 122.88 meters west, and we are also traveling 87.04 meters south. Using our tail to tip method, we are now going to be solving for our total displacement, and again, because it's a vector, we need to find the angle. To do this, it is just Pythagorean's theorem. Displacement is equal to the square root of 122.88 meters squared plus 87.04 meters squared. When you calculate and solve, you're going to find your displacement is 151 meters, and we also need to determine our angle. Our angle, again, we have the opposite and the adjacent, so we're going to use tangent. Inverse tan is inverse tan of 87.04 meters south divided by 122.88 meters west. Remember, opposite over adjacent. Opposite over adjacent. When you calculate, you are going to get an answer of 35.3 degrees south of west. South of